Hello everyone, this is my English speaking practice and I'm working on coding problem. Today's problem is range sum query 2D immutable. Let's go. Hmm. Uh. Hmm. Okay, it's connected. Given a 2D matrix, handle multiple queries of the following type. Calculate the sum of the elements of matrix inside the rectangle defined by its upper left corner, row 1 and row column 1, and lower right corner, row 2 and column 2. Implement the num-matrix class. Num-matrix initializes the object with integer matrix, and the function sum_region returns the sum of the element of matrix inside the rectangle defined by its upper left corner and lower right corner. You must design an algorithm. You must design an algorithm where some region works on O of one-time complexity. So let's take a look at example 1. Input is initialize the num-matrix class and 3 queries. So what is maybe this is the first query, and row second and column 1. Is this 0 indexed? Row second 0 1 2 3 4 0 1 2 3 4, so 2 1 here and 4 3 is here. Okay, 0 indexed. Apparently this is 0 indexed. So the first query's range is like this. So we have to return the sum of this region. 2 3 4 5 6 7 8. So the answer is 8. Okay, got it. Huh. Yeah, interesting. The first idea that comes first to my mind is accumulating the sum of the range from the 0.0, and each point have its total value. So in this and calculating specific range, we do some math. So in this case, first we can get the total of this range, and we have to subtract some value from this. Okay, so yeah, basically it's like here and here, right? And this is possible because this point also have the total value from the 0.0, so we can subtract the value, which can be which can be calculated already, and this is also calculated. And at this point we subtract this area twice. So yeah, at last we have to add this area, right? Yeah, that's how we can get the total of this area, right? So that's good. I think this is good. So let's get started to implement this. So obviously the time complexity is O of 1. It's a constant time because we can calculate the total value from 0.0 at the first time. So every query comes, we can return the total value for a specific area in a constant time. And yeah, and for the space complexity, it is like n by n, because we have to store the total value for each cell, right? We need to store all the values, so the time space complexity is n by n, which is not too large, so it's I think this is not problem. Okay. Okay, so let's code it, and I'm gonna go with Rust, and I'm a beginner of the Rust, so so I'm going to use range sum query to the immutable, and and there is a struct, and I should implement two functions. Means the method takes an immutable reference. If you need a mutable reference, change it to a mute self instead. Metrics. Okay. The problem is how do I calculate the total value from by the point 3, 0, 4, 8, 10, and this, so it's so at this point it should look at the cell above it, right? This point above it and left on it, right? Above it and left on it. We can get the total value at the point. So it takes matrix. But once the total value is calculated, the original matrix is no longer needed, so we can use this matrix for storing the total value, right? Yeah, we don't need to prepare another matrix, right? Overriding it on this. Yeah, let me try. But I'm not sure. Oh, okay. I should declare field like vector integer 32-bit, right? And maybe, yeah, like that. Cannot find the matrix in this scope, but it's matrix, right? Okay. Yeah, maybe the ownership is this function takes the ownership, so we can modify this variable, right? Okay, so it's like m and n, m matrix length let n is matrix lengths, right? And the not empty, at least one, right? So we can get m and n, and for I in range, not range 0 to m, and for I in 0 to n, for j, right? Get value v, yeah, matrix I j, right? Matrix I j is cannot borrow matrix as mutable as it is not declared as mutable, cannot borrow as mutable. Okay, mute. Okay, that's nice. And this is not correct because we should get above. Get above is matrix I minus 1 and j, right? And the left is matrix I j minus 1, right? But could be, yeah, out of index. So how do I Boolean types functional style. Boolean types functional style. Boolean conditional branch. If that's not good. I see. If expression is like this, and this is also j minus 1, we can get the value, and otherwise 0, and the total is v and above and left, right? That's all. And for the queries, some region. Okay, we can get wait. Okay, if let mute total is self matrix and row 2 and column 2, right? And we have to subtract some values. It's based on the row 1 and row 2. If row 1 is greater than 0, we can subtract yeah, self matrix, yeah, row 1 minus 1 and row column 2, yeah, column 2, yeah, and likewise 0 greater than less than column 1 should be subtract by matrix row 2 column 1 minus 1, right? What it's I32. It is typecast. is this? Ah, I see. And finally, low one and core one. Yeah, we can get the value low -1 and column -1. What? Comparison operators cannot be chained. This and return total. Right. What is saying? What does it saying? Comparison is useless due to type limit. What? Unused comparison on by default. Why this is not used? I might be 0, so what? Ah, I see. This type is U size, so it's never be under 0. I started. Yeah. Functional expression for if branch interest. I feel like different one. There must be different one. Option. Yeah, I'm wondering about this expression, but it seems returning option types. Let me see this expression. Oh, what is it? I see. then some and or okay unwrap or else unwrap or 0 put above. Yeah, I like it. I like it. So this case left, then some unwrap or 0. That's all. Yeah, I like it. Okay. Let's test it. Boy. Runtime error. Index out of bounds. The length is 5, but the index is 1A4467440737095516115. What the fuck? Maybe. I should like this. And that's not good. I see. So as U size. As U size. Okay. Yeah, that's a difficult part of Rust, but it's important to think about various type, how the memory is used, and how the value is represented. That's an important thing. So thanks to these strictness stringency thanks to these strict rules we can we are getting aware of how the value is represented in a binary format, right? Yeah. So the last lang is not not useful for these kinds of problems, right? Because compared with Python, we have to write a lot like this. Okay, do it. Okay. What? It's my what? I is not good. Huh? No. I integer unsigned. You. Huh? U size is U size unsigned integer type, right? Yeah. So I 32. But the problem is then some, true, then some. Why? Well, it's true. The indexing expression is evaluated before then sum runs. Then sum is not lazy, so at I0 this gets evaluated first. But I think does not become true So the problem is evaluation, even though the condition is false, the argument is evaluated. I see. Okay. Yeah, that makes sense. Then some. So it's, yeah, have to they have to make it function for lazy evaluation, right? Yeah. And wrong answer. Really? Really? Above and for we have to subtract this one, right? Hmm? Wait. So above left is this condition is met, then get I minus 1 and j minus 1, and then unlap or 0. Like this. Let me see. Correct. Submit. Great. This is the first test answer. Oh. +1 and +1. Okay, good. Let me solve one more question, one more problem. An additive number is a string whose digit come from an additive sequence. A valid additive sequence should contain at least 3 numbers. Except for the first 2 numbers, each subsequent number in the sequence must be the sum of the preceding 2. Given a string containing only digit, return true if it's an additive number or false otherwise. Note that number in the additive sequence cannot have leading zeros, so sequence 1, 2, 0, 3, 1, 0, 2, 3 is invalid. 1, 1, 2, 3, 5, 4. The digit can form an additive sequence 1, 1, 2, 3, 4. 1, 2, 3, 2, 3, 5, 3, 4, 8. I see. So 199 gonna be 100 and 1 9 and 100. No. What is it? 99 and 100 is 199. I see. The length is 35 at most. It feels difficult. Because we have additive number. Additive number. Yeah, we have a lot of combinations. How to explore all states, right? Explore all states. string. Charles. True or false? True or false? So basically, have to look at one by one. Should be start from right side. So when look at 9, the minimum candidate is 1 and 9, because yeah, you can see 9 9 1. So this is a minimum candidate, but it's not good. So 9 is impossible as a last value, right? So the second candidate, second possibility is 99, and yeah, and 0 is not 0 itself is valid, but the leading 0 is not valid. So the first possibility is 0 and 1. It's not good. How to yeah, this is just this is only addition happens, so we have to look at two values and adding digits and try to make it more larger value, and if the total of them are over the target, we can stop it, and we can move on to the next, right? So in this case, first possibility, and for the right side, the second possibility is like this. So this is not good, so we can stop it for 99, right? And the next try is 199, and the right side is 0 and left side is 1. At the first time, it's not good. So the second challenge, the right hand gonna be 100, and it seems good. So strictly speaking, 9 is tried. 9 is applied at the first attempt. It's not enough, so second attempt is 99, and that's good. So we can find this combination, and when we find the valid combination, the right hand is the next target, and left hand is right hand is already fixed, right? So we expect x is 1, and in this case x is 1. So that is good combination. I think this is good. What is the time complexity? Look at 9. Blah, blah, blah. Look at 99. Blah, blah. this recursive structure, and the base case it takes a string and remaining string and left and right. Right and target maybe, and so basically return check string minus left. Target should be right. Yes. If string the string which is taken from the left, right, it should be target minus right. If it's true, it's valid, so we can go next, and otherwise return false. Base case is it's true and this is empty, return true. This is a base case. So the problem is we need to explore all combination of target and right value, right? So let me write in Python because I'm not good at handling strings and conversion into numbers. From characters to numbers. So target possibility is like I in range yeah, it is until half of the original string. Because it's a size of digit, so it's enough to check until half plus 1, right? And target is like num I minus I. So this is like this. Look at 9 and look at 99, look at 199, like this. And this is the inner loop. This is so range I, because the right value could be the value that have same number of digits, right? So it j increases until I, up to I, right? So the right value is like j2 minus I. It's not it's not correct. I mean so let's assume the size is n, and look at I, and going this way, and j is going this way, right? So this expression is not accurate. Like this. And if right less than or equal to target, call the check function, and the string is like this, and yeah, and the right and the target. If let is true, return true, and if we cannot find any answer, return false. So sudo code. Implement a full added number checker using string-based addition to avoid integer overflow with explicit handling for reading zeros. The sequence is validated by growing sums from the first two numbers and matching the remaining suffixes. Why did you change my algorithm? This is totally different from mine. I is 1 to n minus 2. Check sequence first len and second len. First and second len. Updated the implementation to validate sequence from the right, matching your pseudo code. Pick target and right, compete left, and work leftward. Key changes in new right to left check prefix. string subtraction. Remove forward adding logic. If you want to again, this case. Let me see. Target start. Oh, this syntax is also valid in Rust. Okay. And the right len is 1, 2 minus target len. Yeah. Check prefix. A little bit complicated, this implementation. Subtract strings. Why don't you convert I kept it as string to avoid overflow. In read quantitative number, their number can be arbitrarily large, up to length of the input string. So isn't safe using built-in to be correct, but as a dependency and overhead. Efficiency, string-based sum is O of k per step, where k is a digit count, which is fine for n less than 35. Length is 35, so the number could be too large. Okay, and I understand. Converting to integerability and yield risk overflow or read by manually. So this is both safe and fast enough. Okay, I see. I understand. Subtract string is like this. Let me check this solution first. I'm going to review and learn Rust grammar later. Correct. So the logic is mine. Logic is what I came up with, but the implementation is not mine. So target ranks. I think this could be Cosmo or something. Perfect. Okay, let's see how it's implemented. This is good, this is good, this is good. And target start is good. Yeah, this is storing to and we can use slice syntax like Python. Okay, and is valid number. Yeah, this is one or is valid. So it's opposite of invalid. The length is 1 and it starts with 0, it's invalid. The length is not 1 and it starts with 0, it's invalid number. So this function is useful and correct. And here, so what we want to do here is like this. Yeah, right start and so what so the target length and right length. It's not difficult. And check prefix. Compare numbers. For just comparing, we can use bytes. Okay. Okay. And the most difficult part is here, subtract string. So the A and B is numeric value, but it could be too large, so we cannot use integer type even if it's 128 bit. So we need to subtract large values, in the form of in the string form, right? So first convert to byte, and what is it? Yeah, it is number of number of numbers, number of digits, yeah. And since this is subtraction, so we have to use borrow. This makes it more complicated. And this is the answer. This is the answer, right? Basically, we can convert it into integer like this, because this is character. This is a this is a byte. This is a byte that represents the number in the ASCII format. So subtracting by the byte which represents 0, we can get a byte representing the value. So we can regard it as a integer 8-bit type. So this is the value should be used for subtraction. And right, A and B. Target is A and right is B. So we do A minus B. Right, and if J is more than 0, what? 0, 0. I see. So subtract from the smaller values. Subtract from the smaller values. So the digit could be below zeros, and at the time, if it is, we have to borrow the 10 from the next digit. So adding 10 and borrow is set to 1, and then digit is one of the part of the answer. And digit is represents a difference. Digit is a byte that represents the difference. So in order to convert it to into a character, have to add a offset, and it is 0 in ASCII. 0 in ASCII. And I and J. Yeah, INJ, yeah. INJ are decreasing. That makes sense. And after that, what is what? If it's 0, we have to remove it. If it's 0, we have to remove it. Is it? Could be. Could be 0. Could be 0. Reading zeros. I'm not sure about a case where the leading 0 happens, but yeah, this part removes leading zeros, right? And finally we have to reverse it. And convert it to string. Okay. That's all. Yeah, but I didn't know this one, so yeah, I feel like I don't want to convert string to characters and character to integers or something like that. But yeah, it is good to know about this. This is like Python syntax, so we can use we can use handle string slices easily. And check prefix, this is this is good algorithm, I think. Subtract left, let's see, and this is beat 100%, so I'm glad. Oh, parse int. But it use U64. maybe 35. 35. I'm not sure how large the number is, but the follow-up question is, how would you handle overflow for very large input integers? So as a normal solution, we can use like this, I think. And 2 byte. What is it? And I want to know time complexity. So it is this seems nested loop, but actually it is just going linearly, so this part is linear. And check prefix, this is also checking left one and checking left one and checking left one. So this part is also linear. So so overall this is squared algorithm, I think, because the loop is exploring for the first candidate. So this and this and this and this and this and this, right? And for each candidate we have to decide the composition, yeah. Target are composed of right and left, and the target are composed of right and left, right? So I'm not sure this is squared or not, because for the one candidate we have multiple composition, right? So I'm not sure about this. So let me see. they doesn't mention complexity. This is not complexity. Oh. This solution works by checking all possible combinations of the first two numbers and then iterating through the rest of strings to check if forms a valid additive sequence. We start by iterating over possible point positions for the second number, which must be at least one position after the fourth number. We then check if either of the first two numbers have leading zeros, which would make the sequence invalid. We then calculating the next number in the sequence and checking if it matches the remaining string. If it does, we continue iterating with the next number in the sequence, and if we reach the end of the string, we have found a valid additive sequence. If we have all check possible combinations of the first two numbers without finding a valid sequence, we return false. This solution has a time complexity O of n cubed, which is better than the brute force solution. Yeah. Okay, I see. Yeah. I'm starting to feel like doing it from the left would be almost the same. So we have to we have to check all possibilities. So for the first candidate, we are going to check one by one until almost half of n, and then check possibilities for second, and then if that some of them found in the at the remaining part, we can continue to the continue to exploring, and first and second value are already fixed, so we just check the total value, so it's almost same. Yeah. I see. Okay, let's finish. Let's call it a day. Thank you for watching. Bye.